when a vector is given in terms of the unit vectors I and j, you can find its magnitude using Pythagoras theorem. And the magnitude of a vector A is given by magnitude of a vector, magnitude of a vector A is given by A modulus. And let's see this in example 9. Given that vector V is 3i minus 7j, find the modulus of V. V is 3i minus 7j. If you are starting from here, then you could call that 3i minus 7j, because negative, we have to go down to the negative side of the y-axis. This is V, which is 3i minus 7j. And of course, so the modulus of V is just the normal way you use the Pythagoras theorem, is going to be equals to the root of 3 squared plus negative 7 squared, which is the root of 9 plus 49, which is the root of 58. And the modulus of V is given by 7.62, of course, to 3 significant figures. That is as far as example 9 is concerned. But let us look at example 10 here, because they have something in similar. Example 10. Example 10 is asking, find the angle between the vector 4i plus 5j and the positive x-axis. Find the angle between the vector 4i plus 5j and the positive x-axis. If this is the y-axis and this should be the x-axis, then 4i plus 5j, 1, 2, 3, 4, 1, 2, 3, 4, 5, that is the vector, because we have to go 4 steps along the x-axis and of course 5 steps, 5j along the y-axis. So this is the vector, let's call it vector A, which is 4i plus 5j, and we are supposed to give the size of the angle between the vector and the positive x-axis, in short, the value of theta. And using Pythagoras, or rather trigonometric ratios, and with our knowledge of SOHCAHTOA, we know that as considering the position of this angle, we have the opposite and we have the adjacent. So the tangent of theta is 5/4. And our value of theta is the tangent inverse of 5/4, which is basically 51.3 degrees. So the angle between the vector 4i plus 5j and the positive x-axis is 51.3 degrees. And I hope that is just clear. All right.